shape. We've already talked about circles and ellipses, and we're going to look at something called a hyperbola. And notice that the x squared term and the y squared term this time have a minus. So let's look at what that's going to look like. So I'm going to go to Desmos, because the beauty about Desmos is that you can type in these conic sections, that's what they're called, straight in, and we can kind of get an idea of what we're looking at. So I'm going to pull this one out. Whoops, I meant to pull this out and shrink the screen so you can see it a little bit better. So this ends up giving me not an ellipse where they're going together, but it's giving me two separate parabolas, two separate branches. So a parabola would be one of these branches. A hyperbola is two of these. So I want to talk about this equation. And if we think back on what we were doing with ellipses, if I took this equation and I divide both sides by 144. This is going to be 9 over 144, which ends up giving me 1 over 16. And 16 over 144 ends up giving me a 9. And then 144 over 144 is a 1. So this is very similar to an ellipse, except for it's got a minus sign instead of a plus. Now, a squared, this is 4 squared and 3 squared. So instead of having that ellipse where we go out 4 and then up 3, we're still going to count out 4 left and right, since that's underneath the x squared, and I'm going to go up 3 and down 3. But I'm not going to make an oval from that. I'm going to make a rectangle. Oh gosh, I just got crazy. Rectangle, rectangle, and a rectangle. So I counted out 4, up 3, down 3. The next thing I'm going to do is actually make diagonals. So I'm going to go and do a diagonal. These are what are called slant asymptotes. These are going to be the boundaries for my two pieces or branches of the graph. This graph's going to get close to those diagonals, but it won't touch them. Now, since this started with an x squared in front, because it has the x squared, the x is in front, that's going to give me a horizontal hyperbola. If it had been switched and it was y squared over 9 in front, it would go up and down. Now, the technical geometric definition is that it's a set of all points in a plane whose difference from the foci is constant. So it's going away from the foci. So the foci would still be in here, in between, in my rectangle or in my oval, but I'm going away from it for a hyperbola. Now, if the x minus h squared is positive, then we're opening left and right. If this one was coming first, if the y was first, it's going to open up and down. We're still going to find the center, count out our horizontal distance and our vertical distance, draw a rectangle, and then make those diagonals. Now, to find our foci, it's a little bit different. For the foci, this is for the foci, it's c squared equals a squared plus b squared. So all I have to do is add those denominators and to find the c. Now I need to know if I'm opening left and right to find the foci for this one. So I need to know if I'm adding to my x value, my h, or if I'm adding to k, which is the y value of the center. So let's start with this one. What would be the center? Well, x plus 2 means the center is going to be at -2. Center is going to be at -2, 5. A is 4, B is 5. So the first thing I need to do is mark the center, -2, 5. I'm going to count out 4 horizontally. 1, 2, 3, 4. 1, 2, 3, 4. And then up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now instead of that becoming my oval, this is going to become a rectangle. I don't know why I'm singing to this. Okay. Now I can go ahead and fill in the major axis and minor axis since this is larger. It's 5 and 5, that makes this a 10. 4 and 4 makes this an 8. Draw your diagonals. Now, the two branches, because x squared is first, it's going to open left and right. So I'm going to this edge of the rectangle, right where that dot was, and I'm going to open this way. And right here, I'm going to open this way. Now, the next part is finding the foci. And the formula up there was c squared equals a squared plus b squared. So I'm going to add those two together. So a squared was 16, b squared is 25. That's a 41. So c is the square root of 41. Now the foci, the hyperbolas are running away from it. So they're going. So the foci are going to be left and right from the center. So I'm going to have to add to the x value and subtract from the x value, not from the y. So here's the x value is -2. So I'm going to take -2 plus the square root of 41. And then -2 minus the square root of 41. Sample 2. Oh, it's switched. So we have to be careful on the center. X minus 4. So this is a 4. Y plus 2 is a -2. My A is 3 and B is 5. So I'm going to start at the center, 4, -2. Count out left and right, 1, 2, 3. 1, 2, 3, 1, 2, 3, 4, 5, up and down, 1, 2, 3, 4, 5. That means my major axis is 10. The minor axis is 6. Here's my rectangle. This is just helping me graph. I'm going to draw my diagonals in. You don't have to be perfectly exact on the diagonals unless you want to. If you wanted to get a ruler out, you can. Now, since the y is first, instead of it opening left and right, it's going to open up and down. That also means the foci are going to be up and down from the center. Up and down. So I'm adding and subtracting from the y. But I need to know what to add and subtract. So c squared for hyperbola is a squared plus b squared. So a squared be 9 plus 25. That's a 34. So c is the square root of 34. I need to add that to my y and then subtract it from my y. Last one. And of course we picked the doozy for last. It's all mixed up. Okay. So the first thing I need to do is group my variables. I also think I want to put the positive one first. So I'm going to put 25y squared plus 100y minus 4x squared minus 24x. Whoops. Then this constant I'm going to move to the other side. Now, I'm going to factor out the 25 from the first two terms. And I'm going to leave a space. Here, I'm going to factor out a negative 4 from each of these terms. Now, whatever I add here and add here, I'm going to have to add to this side. But remember, this has a number in front of the parentheses. So the first one is going to be plus 25 times something. And then plus a negative 4 times something. Half of 4 is 2. 2 squared is 4. So I'm going to be adding a plus 4. So this is going to be a 4. Half of 6 is 3. So this is going to be a 9 and a 9. Okay, so this is a 36. This is a negative 36, so I'm left with 100. Divide by 100. 25 into 100 leaves me a 4. This would be a 25. So my center is going to be at negative 3, negative 2. A is 5, B is 2. Here's my center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. So my major axis is 10 long. The minor axis is 4. I'm going to make a rectangle. Draw some diagonals. And this one had the y in front. The y squared was positive. So it's opening up and down. And you don't have to be perfect on these. To find the foci, c squared equals a squared plus b squared. That should look so familiar. This is 25 plus 4. Since this graph is opening up and down, I'm going to add to the y, subtract from the y. And that's it.